Exercise 17 deals with the cardiovascular system. For this lab, what we're looking at, we've already looked at the heart, so now we're looking at the blood vessels themselves. So with the blood vessels, this is just kind of a drawing once again for review. You've got your pulmonary circulation, that are the blood vessels going to the from the heart to the lungs and back, and then the systemic circulation is going elsewhere. One thing as you're studying this to keep in mind, some people want to say, oh, if it's red, it's an artery, if it's blue, it's a vein. That is not always true. It's better to learn it that arteries are moving blood away from the heart and veins are bringing the blood back to the heart. And part of where that some people get confused with this is with the pulmonary circulation, it's different than the systemic. Pulmonary circulation, you'll notice that your pulmonary arteries that are moving the blood from the heart to the lungs are very low in oxygen. So that's why they're often drawn as blue. And then as the blood is returning from the lungs back to the heart, it's traveling through the pulmonary veins. That's very, very high in oxygen, and so that's why it's often drawn as red. But when you're in the systemic circulation, the blood leaving the heart through the aorta, and then as it branches down to the various other arteries, it's going to be very high in oxygen. So that's when like the aorta is typically shown as red. As the blood travels throughout the rest of the body, and then that blood is then returned back towards the heart, as it's returning, it's already dropped off the oxygen. So now it's low oxygen, high CO2. So that's why it's often drawn in blue. So just think about, where is the blood traveling to? Where is it traveling from in terms of, is it high oxygen or low oxygen? And then just in terms of, is it artery or vein? If the blood is moving away from the heart, it's artery. If it's moving towards the heart, it's a vein. So when we look at the blood vessels themselves, as I just said, your arteries are carrying blood away from the heart. They tend to have very thick walls. They have very high pressure, so that's why they have the thick walls, so they can withstand that high pressure. As the arteries get further and further away, they start to branch. The blood flow is going to slow down a bit. Blood pressure is going to decrease a bit. And as the diameter gets smaller, they become what we call arterioles. The arterioles then connect to the capillaries, which are, in terms of diameter, are the smallest diameter of all the blood vessels. This is the site where actually the gas exchange and nutrient exchange and waste exchange occurs. This is in the capillaries. Then the blood flows to the venules. Now your diameter is going to start getting larger again. And the venules basically are connecting the capillaries to the veins. They tend to get larger and larger until you're in the veins, and they're returning the blood back to the heart. The walls of veins is thinner than the arteries because the blood pressure is much lower there. So this is just kind of a diagram showing that your blood is flowing through the artery to the arterioles. It branches, it's getting smaller and smaller. Now you're in the capillaries. This is where the exchange is occurring. CO2 is leaving, nutrients are leaving. You also are going to have carbon dioxide and waste products moving from the interstitial tissue area into the capillary blood, and then it goes to the venules and then to the vein, and now it's going to go back to the heart. When you look at the structure of the blood vessels, usually there's three layers: the tunica intima, tunica media, and the tunica externa, or sometimes known as the tunica adventitia. The tunica intima, that's the innermost layer. It has smooth muscle, has epithelial tissue, connective tissue, and in capillaries, this is the only, it looks very smooth, this is the only layer that's present in capillaries. The tunica media is composed of smooth muscle. It is much thicker in the arteries than in the veins because, once again, it has to do with higher blood pressure, and so that thickness helps it to deal with that pressure. And then the tunica externa is the outermost layer. This is going to be the thickest layer in veins because remember they have less pressure. It is composed of connective tissue. So this is just showing a schematic drawing of arteries and veins in terms of, look at the thickness here of the tunica media. Remember, this is the smooth muscle, so you can see it is much thicker in the artery. Because it is thicker in the artery, the other thing to notice if you are looking at a slide, notice how on the artery, the shape, you can see it's got this shape, this white area here, this is where the blood is actually flowing through. On the vein, it looks like it's collapsed. Why? Because it has a much thinner muscle, and so when they take a slide, there's no blood in there to help keep it nice and firm, and so the thinner walls, yes, it does collapse. Keep in mind, obviously, in the body, you've got blood flowing through that's going to help keep it open. So we look at arteries, we can divide them into elastic arteries versus muscular arteries. The difference has to do with how much elastic fibers is present. Elastic arteries have a larger diameter, and muscular arteries have a smaller diameter to them. The arterioles have a smaller diameter as compared to the arteries. That blood flow is slowing down because it's smaller diameter there, and you tend to have lower blood pressure. And so this diagram is just showing a comparison of the two different types of arteries as well as compared to the arteriole. Then you have what's known as a meta-arteriole. This connects the arteriole to the capillary, and it's going to help regulate the blood that is flowing through that capillary bed. In just a moment, I'll show you a picture. It would be better explained there. You have small circular smooth muscle, so it's involuntary, that surrounds the capillary. That's what a sphincter is a circular muscle. These are known as the precapillary sphincters. It's right where the capillary attaches to the meta-arteriole, so these can contract and keep it closed, so the blood flow, basically you're forcing where is the blood flowing. So do you have the main channel act like a shunt, or do you open it when you need the blood flowing through that area? So once again, this picture is going to show this much better. So here we have the arteriole. The meta-arteriole is connecting the arteriole to the capillary bed, which is this entire area. So that connection right here is the meta-arteriole, as we said. The precapillary sphincters are these circular muscles right here. So notice if they contract, you will not have blood flowing through there. It can't because it's closed. It's going to force all of the blood to, like I said, kind of like a shunt, to move through here. If these do not contract, if you need blood flowing in this particular area, these open up, and then it would allow the blood to flow through here. So it just depends on what's occurring at this particular time. And keep in mind that once the blood has flown through the entire capillary bed, then on the other side it goes to the venule, which then connects to the veins. So the venules, that blood is flowing through there, merge to form the veins. The veins are going to return that blood to the heart. Pressure is very low in the veins. To help keep the blood moving and not have it, because it's slowing down, there's lower pressure, to keep it from backflowing, veins do have valves. Arteries do not. Just kind of FYI, veins do have valves. That's one of the things, if you ever donate blood or have blood drawn, you may notice that the phlebotomist, as they're feeling on your elbow area to draw the blood, you notice they're kind of palpitating or pushing. They're feeling along, number one, with the veins. One thing they're feeling for is you can feel the valve in there. When they go to stick you with the needle, they don't want to go through that valve. You want to go just on the side of it. You don't want to penetrate on the valve. So that's what they're feeling for. So this shows you comparison of the thickness of the walls of the venue and the various sizes of the veins. So the veins are going to get larger diameter the closer you get back to the heart. Now the other portion of this exercise is to learn the various names of your blood vessels. You've already been exposed to what are known as the great vessels. The great vessels are associated with the heart. So you've got the aorta, the superior vena cava, the inferior vena cava, your pulmonary trunk, which then breaks to the pulmonary arteries and pulmonary veins. Now, you'll notice on this drawing that you do have the branching, and we start every time they branch, we're going to give the artery or the vein a different name. A lot of the names are by the area of where they are. In other words, it's like the brachial artery right here. And we're going to look at these more specifically. Where's the brachial region? Well, you already know that's in the arm. Gastric refers to stomach. So if you see something here and like, oh my goodness, I forgot, where's the gastric vein? Think gastric, stomach. Okay, it's going to be up by the stomach. Hepatic refers to liver. Renal refers to kidney. So use some of those little clues to kind of help you with that. As we look at these a little bit more detailed, I'm going to kind of go through it quickly. The easiest way of learning this, once again, is practice, practice, practice. Whether you're looking at models, whether you're looking at some of the review things we have posted, whether you're looking at the photo atlas that we have available to you, or you take print off various images and you label them yourselves, find what works best for you for learning these. So if we start at the head, you'll notice once again, a lot of both arteries and veins are named by the location of where they're at. So you already know and have known since beginning of the semester, occipital refers to the back of the head. So guess where the occipital artery is going to be? Servicing the back of the head. Superficial, temporal one. Superficial, you know, it means more on the surface. And where's the temporal region? Well, that gets you in the right place. The maxillary, where's the maxilla? That's the upper jaw. So use these clues to help you. And then this is showing with the veins. Same type thing. Use the words to help you. Once again, also, don't forget to look at your lab manual that has the list of all the arteries and veins that you're responsible for knowing. You don't have to know all of them. There's so many of them. No, you don't have to know all of them. So use that list to review to help you. Use whatever, I would say, use whatever helps you to learn something. You'll notice there is both an external jugular and an internal jugular vein. They're not arteries, they're veins. Something that actually it was my daughter that commented that helped her to remember where's the jugular when she was learning it. And this is why I say use whatever helps you. She loves Disney movies. And she always remembered a scene from The Lion King when Timon and Pumbaa, it's when there's a fight going on and they're yelling to go for the jugular, go for the jugular. Well, if an animal's going for the jugular, where is he going for? He's going for the neck. Use whatever trick helps you to learn them. With the arm, you've got the subclavian. Subclavian. Clavian refers to the clavicle. So you're going right underneath it. Axillary refers to the armpit area. As I just said earlier, brachial. The brachial artery is going to then divide down into the radial and the ulnar. So use those once again to help you. And then you've got the veins as well. Okay, it looked like sorry about that pause, my computer froze for a second. Here we've got in the thoracic and abdominal area, we have got the arteries, various arteries listed here. Once again, use some of the terminology to help you a little bit, just in terms of orientation, because it looks different. I know with the heart removed from there. Let's try to, this is the diaphragm right here. So you'll notice that the aorta comes down. You've got the thoracic aorta in the thoracic cavity, and then it becomes the abdominal aorta once it passes through the diaphragm and extends down. Splenic refers to the spleen, gastric refers to stomach, hepatic refers to liver, renal refers to kidney, adrenal refers to up here feeding the adrenal glands, as you already know, are on top of the kidneys. Coastal up here refers to ribs. Lumbar is the lower back area. Iliac, you already know, is in this area here on either side. So use those terms just to help you. And just think of it kind of like, you know, a road map. You start with the interstate, and then you have highways breaking off from that, and then you finally have the 2-lane roads, and then you have the little farm to market roads. It's sort of like that. As you leave the heart, you're on the big interstate, and gradually you have the arteries getting smaller and smaller to the arterioles, eventually to the capillaries, and then back. You're returning back to the big city via the interstate. You're returning back. The smaller capillaries, then the diameter gets a little bit bigger as you hit the venules, and then largest at the veins again as you return to the heart. And so this is showing the veins. Once again, use those terms, just practice, practice, practice. And then as you extend down into the leg, femoral region is going to be the thigh. So here you've got the, up here, the femoral artery. Popliteal, that refers to the back of the knee. So you can see on this side over here, it's showing, it goes behind the kneecap. The tibial, it's going to be near the tibia, and you've got the anterior and the posterior on there. And then when you look at the veins, once again, one thing some people will confuse is if you look at, you have the femoral vein. Now, depending on whether you're looking at the posterior or anterior view, just make sure you keep your orientation correct. You've got the great saphenous vein. That, notice, is medial. The femoral is right down the middle, but the great saphenous is medial on here. Regardless, remember, medial inside. Once again, popliteal. And then the small saphenous, that is going to branch off of the femoral below the knee. So use all of those guides to help you with the identification, and keep in mind the structure, etc., of all of your blood vessels.